This is Shobana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. In today's session, we will be seeing about the continuation of functions in the C programming language. The last session we had an introduction into how to use functions in C. In today's session, we will be seeing about the different forms of return statement, the argument passing methods with the example programs, and how to use a function as an argument with operators and recursion, which is a special case of a function. So first, starting with the forms of return statement. A return statement is used to return the result of or the outcome of a function to the function which called it. So this return statement can be expressed in several ways and it can return several different types of values. The most common type is return and within parentheses expression. This expression value is returned to the calling function. The value which is obtained as a result of evaluating that expression is returned to the calling function. If this expression within parentheses is omitted, the return statement does not return any value, it simply transfers control to the main function or the function which called it. What is a calling function and what is a called function has been seen in the last session. So assuming that you understand the meaning for both, here is an example, return within parentheses. I am giving one expression a plus b plus c. Each of these is a variable. A is a variable, b is a variable and c is a variable. So the value which is obtained as a result of adding these 3 variables is returned to the function which called this function. This is the most common type of return statements. A function may use one or more return statements. It is not necessary that if you are declaring a function and defining it, it should have only one return statement. There may be exceptional cases where because of some conditional expression, because of some evaluating expression, we may have to return more than one value depending upon the situation. So that is most common with the use of these decision statements. So here is an example where if the values a and b are evaluated, if a is greater, we have to return a or we have to return b. The same is true for a switch case construct also. If the case 1 is true, then we have to return the value 1, and if the case 2 is true, we have to return the value 2. So such exceptional conditions may occur where in a single function we may have more than one return statement, but the ultimate value that is returned is only 1 in number. The third type of return statement is return within parentheses ampersand p. We have seen this ampersand operator. It is used to hold or signify or identify the address that is held by a variable. So this returns the address of this variable p to the calling function. The variable name is given here only as an example. The next type is return within parentheses pointer variable p. Now we have still not seen what are pointers. A pointer is nothing but it holds the value of an address or the value of the variable that is stored at a particular memory location. So here if I give pointer p, it means p is an address, p represents an address. The pointer variable is used to extract the value which is stored in that address. So here this return statement will return the value which is stored at that particular address which is pointed to by p. The last type is the return within parentheses. You have sqrt is nothing but a square root function. Inside that you have an argument. So here if you see, the square root of r is a function by itself. So this return statement is returning a function. So how will this be evaluated? Here the control from the return statement first goes to the function square root of r. In square root of r, certain statements will be defined. We all know sqrt of r will return the square root of a number. So if I give square root 81, it will return the number 9. So this number will be returned as the value. So this expression will be equal to return 9. So the number 9 will be returned to the function which called this function. So this is how a function also can be passed as an argument in a return statement. So these are the most commonly used types of return statements and their values. Another possibility with the return statement is where we can call a function In addition to that, we can do type conversion also. We all know what is type conversion. When we explicitly change the data type of a particular value or variable. So here we have return, within parentheses we are having float, within that we are having a function square, and I am passing one value. So how will this be evaluated is, first the function square of 2.8 will be executed. So square of a function means 2.8 will be multiplied again by itself. So we will get the square of the number. The number should be explicitly returned in the float data type, that is, it should not take just the integer value and return it to the function. We want the answer in the float data type with the exact decimal and fraction. So that is the reason we are explicitly converting that square of 2.8 into a float and we are returning the value. So this also is permissible in the C language. See, all these are all that is permitted in C language. Depending upon our application and our need, we can modify these statements and use only those kinds of expressions which are required for us. It is not necessary that because they exist we have to compulsorily use them in our programs. It is all available. It is up to us to use them to our benefit when we program. Then we have something called void functions. It's not necessary that every function should return some value. Sometimes we may print the value of that result of that function in the function itself. In such cases, a function need not have a return statement. So there we should explicitly mention that those functions are called void, that is, they don't return any value, they return simply null. So such functions are called void functions. So these are the different types of return statements available in C. Next we move over to the argument passing methods. Argument passing methods, in the sense we know there are two types of arguments, actual arguments and formal arguments. The variables that follow a function call or a function definition are called the arguments. So the variables in a function call are called actual arguments. The variables in a function definition are called formal arguments. So there are two ways in which you can pass these arguments. One is using call by value. The other is using call by reference. Reference is just another name for address. So we will see in detail how these functions are defined or how these methods are defined. Call by value. Here the values of the actual arguments are passed to the function. So this is a normal way of passing an argument. You have a function, say sum, and you pass integer a and integer b as the arguments. Any change which is made to the formal parameters does not affect the actual parameters. So here if you are calling in the function sum of a comma b and you are defining the function sum of c comma d, that a's value will be copied to c and b's value will be copied to d. Whatever changes you want to make, you make inside the function and you print the values there itself. No change that is made to the formal parameters will be seen in the actual parameters. You will understand this better when we see the example programs. What you have to remember here is, in call by value, only a copy of the original value is sent to the function which is called. No change that is made in the function has any effect on the actual arguments. Whereas in call by reference, we don't pass the value, but here we pass the address or the reference of the actual parameters to the called function. So here any change which is made to the formal parameters is also affected in the actual arguments, because here we are manipulating the address of the variable and not its value. So automatically when the address is affected, any value which is stored at that particular address will be automatically changed. So here the modifications or the changes that are made are permanent. You will see its effect in both the called function and the calling function. Whereas in call by value, only a copy of the variable is sent to the called function. You can make any changes you want over there, it will not be seen in the original value. So we will see how these arguments work. So this is an example program for call by value. In this program what we are doing is we are actually swapping the values of two variables. Say I am entering two values 5 and 7 for x and y. I want the values to change to 7 and 5 for the same variables. So here one method I am passing call by value, another method by call by reference. So according to the definition, when I use call by value, that x and y values should be changed only in the called function. Its effect should not be seen in the main function. Whereas in call by reference, the effect should be permanent. It should be visible in both the called as well as the calling function. So we will see how this is executed in C. So here I am declaring the variables and I am declaring the function also. The name of my function is change. I am having two integer variables and I am printing enter x and y value. I am scanning the values 3 and 4 for x and y. So now x holds 3 and y holds 4. Next I am calling this change function. So that is the function call. So what happens when the compiler sees this statement? Immediately the control will go to this change of x comma y. So the control will go to this particular function and it will check whether two integer variables have been sent over here, because there are two integer variables declared here. So the x will be copied to A and the y will be copied to B. So now x is having the value 3 and y is having the value 4. A will become 3 and y will become 4. So here I am having this integer k, which is a local variable. I want to interchange the value, so that this is the logic for interchanging. The value of A is sent to k, B is sent to A, and again the value of A I am copying it to B. So in this way, if you see, the value of A is changed to 4 and the value of B is changed to 3. So the values have been interchanged over here. And here if you see, I am printing the values in the change function itself. I am not exactly returning any function. So in change, when I am printing the value of x is 4 and the value of y is 3. So here if you see, the value of B and A have been swapped, that is, they have been interchanged. So these values I am printing them here in the change function itself, because the ultimate aim of my program is to indicate that in the change function the values are swapped, but in the main function the values remain the same. So the printf statement I am giving in the change function itself, so the output will appear like this: x is equal to 4 and y is equal to 3. Because that is how I am printing it here. X is equal to %d, y is equal to %d, and I am printing the values a and b. I am using a and b here because here the variables a and b are only declared. So what happens after this change function is printed? Now control has to get back to the main function. So there is no return statement here to explicitly return the control. So only when this closing brace is encountered, the compiler understands that okay, now the function is over, I have to get back to the function which called it. So in this case, as soon as the closing brace is encountered, we come to this function. So here if you see, I am again having a printf statement, and here I am printing in main x is equal to %d and y is equal to %d x and y. So the output will appear like this: x is equal to 3 and y is equal to 4. Though the values have been swapped in that function change, and though the function has been called over here, whatever changes were made in that function change is visible only to that function. So that is the reason the values have been printed there itself. There is no modification or no effect on these actual arguments. So that is the difference between these two: x is equal to 3 and y is equal to 4. And here I am closing this main function with the return 0 statement. It is not a must. You can have that statement or you can close that statement. There is no difference. So this is how a call by value program is executed. You simply have to enter the values and call the function as usual. A copy of the value goes to the calling function. Whatever change is made over there remains over there. It does not have any effect on this main actual arguments. So next we move over to the call by reference program. So the same program I am going to execute, but with call by reference. That is, I am going to pass the address of the variable. Now here if you see, you will see that whatever change is made in the calling function will have its effect on the called function also. So here again I am declaring the main function integer xy, and here if you see the change function, it is int star int star. That means I am passing the pointer variable. Now star or asterisk indicates a pointer. So in change, this is the first difference between call by value and call by reference. In the function declaration itself, there we had passed only int and int, whereas here we are passing pointer variables as the arguments. Now what is a pointer? It is something that holds the value of an address. So from that itself it is clear that here we are passing the address of a variable. To access its value, we have to use the pointer variable. So this is the first difference between the call by value and the call by reference. Then we are entering the two values x and y. We are scanning the values. I am giving the same values 3 and 4, and I am executing this function called change of x and y. Again here if you see, there is a difference: ampersand x and ampersand y I am passing. This ampersand is nothing but the address operator. That means I am passing here the address of x and the address of y. So here if you see, the variables 3 and 4 have been written like this. So this is the address at which the first variable x is held, and this is the address at which the variable y is held. So when the change function is executed, we will see that these values are swapped. So how these values are swapped and what happens in the change function, we will see it after the break. Welcome back after the break. So we were seeing about the example program for call by reference, how the values are swapped and what is the difference between call by value and call by reference. So in this call by reference, the first difference was in the declaration of this change function where we are passing pointer variables, and while making the function call, again we are passing the address of the two variables rather than simply the value. So that is a second difference. So what are we actually passing over here? Here if you see in this change function, you have integer pointer variable a, integer pointer variable b. So this is equivalent to the x and y which was passed over there. So there we are passing the address x and address y, and here we are passing pointer variable a and pointer variable b. So the address that is passed over there, to access its value we need these two pointer variables. So this pointer a will take the value which is stored at the address x, and pointer b will take the value which is stored at the address y. So that is why we are using this asterisk symbol over here, or it is also called the pointer symbol. So here I have to declare again a pointer variable. I cannot simply use a variable because my values are all in pointer variables. So pointer k, the same operation is done again, only thing is the introduction of this pointer variable. So the value of a I am assigning to k, the value of b to a, and the value of k to b. So the values have been swapped over here. So I am printing the value again in change. X is equal to the value held at the address a, y is equal to the value held at the address b. So here if you see, the values have been swapped, and again I am not returning any value over here. So only when the compiler sees this closing braces, it will identify that this function's execution is over, the work is done. So we will return the control to the calling function. So when the control is returned to the calling function, all the changes that were made in that change function will be affected over here. That is why here in the print function, if you see, in main x is equal to %d, y is equal to %d, the same x and y I am printing, the values appear changed. The values here is 3 and 4, but the values that are there in the main function is 4 and 3. The values have been swapped. So in this diagram also I am showing how the values have been swapped. 3 has come to where 4 was and 4 has gone to the place where 3 was. How is it possible? That is because the 65550 and 65552, it is only an example of the memory location. Here both of them are integer variables, so they occupy only 2 bytes. So the first variable is stored at 0 and the second variable is stored at the place 2. So here I am passing this address only here in the change function. So change of ampersand x means this address would have been passed. Change of ampersand y means this address would have been passed. And as soon as this function call is indicated, when control passes over here, A will be holding the address, B will be holding the address. So to access their value only, we are using the symbol star. So 65550 is the address, the value there was 3. 65552 is the address, the value there was 4. So that is why using those values they are swapping this values again. So this is the difference between call by value and call by reference. In call by value you don't have any ampersand symbol or pointer symbol. You are simply passing the copy of a value to the calling function, to the function which is called, and you are swapping it. All that happens ends over there. In the main function there is no change. Whereas in call by reference, since you are passing the address and you are using the pointer variable to access the value at that address, any change that is made to that value at that particular address will be permanent, because the address is a permanent location for a variable. That is the reason whatever change is made in the called function has its effect on the calling function. So with these two example programs, it has been indicated that changes which are made in call by reference are permanent, whereas in call by value they are temporary. So next let us move on to the use of function as an argument. So we had already seen an example in the return statement where the function was an argument. Arguments may be values of variables or addresses of variables. So even when you are using function, we can have a value or a variable or the address of a variable. Let's see in pointer p, ampersand p, and so on. A function itself can also be passed as an argument. So when a function is passed as an argument, how does the compiler execute it? So this is a program to pass a user defined function as an argument. Functions are of two types. Library is built in, and user defined is what the user defines according to his convenience. So we will see how this program is executed, how the compiler executes such a program. We start with the main function, and here we have declared two variables, y is 2 and x. And here if you see, x is equal to, double itself is a function, within parentheses the square is a function, and this y is an argument. So you are having these many arguments over here, double, square is the first argument, this y is the inner argument for that square. So what happens when the compiler sees such a statement? This is called the inner function, square is called the inner function, double is called the outer function. So the inner function is executed first. So let us see, the inner function means the square of k is executed first. So there we saw that it was square of y holds the value 2. So instead of this k, it will hold the value 2. And what happens in that square function? We are simply returning the value 2 into 2. So return k cross k, it is returning the value of an expression. So 2 into 2 is 4. So when this return statement is encountered by the compiler, obviously the control will return to the main function. So when control returns here, square of y is holding now the value 4, that has only been returned. So next it will go to the outer function, double of 4. So when this double of 4 is seen by the compiler, it will switch control to this function double. Double of m, that means m is now holding the value 4. And what happens in the double function? Simply returning m into 2. So it is equal to 4 into 2, the value is 8. So when the compiler sees this return statement, it will again return to the main function. So that return 8 is passed on to this collecting variable x. So now the ultimate result of this operation is x is equal to 8. So here we are printing the value of 8. Printf percentage %d and percentage %d, that is whatever value was sent earlier and what is the result of execution. First the value we sent was y, so I am printing that 2, and x is the final value, I am printing it as 8, and then the function is closed. So this is how the compiler executes a program when the function is passed as an argument. Next we see how a function is used with operators. So here we are going to perform addition and subtraction. So again here we have the main function, I am declaring a function integer, name of the function is input, I am passing an integer variable, and I am declaring again a square function and an integer variable, and here I am making the function call. Here again you see you have x is equal to square is the first function, input of x is the inner function, and inside this parenthesis itself I am performing an evaluation with operators 1 minus and plus 1. So how does a compiler execute this program without any confusion? Always the result of the function only will be evaluated first. So as soon as the compiler sees this, it will first move to the inner function. So input of x. So x is nothing but a value which we have to input. So input of x, it will go to this function. So what happens in this input of x? X will be copied to this variable k, and here I am asking the user to enter the value for this x, and I am scanning the value ampersand k, I am giving the value 10 to x, and I am returning k. Now why this x and k is used in an interchanged manner? Because in this function only I am getting the value for x. I am not using the same variable x over here. Instead of that I am using a local variable k. So k and x are just copies of the same value. X is a actual argument, k is a formal argument. So whenever I am scanning a value I am using the variable k. Only when I am printing it I am using the value x, so that the user will understand. Because here we are entering the value of x, only this the user can see. He does not know much about the programming methodology. So it is only for our convenience that we are using a different variable k. So now the value held by x is 10, and I am returning this 10 to the main function. As soon as this return statement is seen, the compiler will move to the main function. Next what it will do, it has to evaluate this expression within the parentheses. So 1 minus 10, because 10 is the value that is returned, plus 1. So 1 minus 10, precedence of operators is minus and plus have the same precedence. So the operation will start from the left hand side. So we are starting from the left hand side. 1 minus 10 is minus 9, minus 9 plus 1 is minus 8. So square of minus 8, that is how the value will be understood by the compiler, that is how it will be executed. So next the compiler will execute this outer function, square of minus 8. So immediately the control will move to this square function, m will be minus 8, and what am I doing over here? I am returning power of m2, that means minus 8 to the power 2. So minus 8 the whole square is equal to 64. This power is a predefined function which is there in the math.h file. So return minus 8 the whole square. So it will return 64. So as soon as the return statement is seen, the compiler will return control over here. Now here x is the collecting variable. So that 64 will be assigned to x, and I am printing the square is 64. So that is the final result that will be obtained. So these are different ways in which a function can be used in a program. So this is with binary operators. We will see the example of this function with another type of operator. Unary operators. We know there are two types of operators. So with unary operators, how a function is used. So again here you have the function declaration. The same functions only I am going to use. Only thing, instead of a binary I am using a unary operator. Again it is the same case. You have x is equal to square of plus y is equal to input of x. Here you are having this plus symbol which is unary incrementing, and here I am having y is equal to input of x. In the previous program with binary operators I did not have a collecting variable here. Why? Because it was a binary operation. Whatever result was obtained, it could automatically be evaluated just like that. But when we are using unary operators, we need to have a collecting variable over here. So that is a point that is to be noted. So what happens is the compiler first executes the inner loop or the inner function. So move to the inner function, you have input int of k. So here again the same thing, I am entering the value of x, I am giving the same value 10, when I am scanning I am using the word k, and I am returning the value of k. So here the value 10 will be returned to the main function. So now this 10 will be assigned to this collecting variable y. So now this y holds the value 10, and what I am doing over here, plus y. So plus 10, which is equal to 10 plus 1. So that is equivalent to 11. So next the compiler will see the outer function, square of 11. So when it sees a function call, it will next pass control to the calling function. So square of int m, we saw that it was equal to square of y was holding the value 11. So now square of 11, inside the function we are again calling the power function m comma 2, that means it is equal to 11 square, which is nothing but 121. So that value is returned to the main function. So as soon as this return statement is encountered, control will return back to the main statement. So the function is now over. That 121 will be assigned to the collecting variable x, and I am printing the value square x. So this is how a function can be used with unary as well as binary operators. When we used a binary operator, automatically the value that was returned was obtained, added and subtracted. Here, because we are using unary operators, we have to have a collecting variable and we have to print that collecting variable only as a final result. Finally, we have recursion. Recursion is a special case of where a function is called repeatedly by itself. There are two types of recursion: direct recursion, which calls itself till the condition is true, that is still a particular condition exists, it keeps calling the same function. Indirect recursion is where a function calls another function and the called function gets back to the calling function. So it is like a relay from one function to another, then to another, and back to the first function. So this is just a small program for recursion. Here I am including the process.h file because I am having the exit of 0 program. I am declaring two variables. I am adding the values of the variables in a recursive manner. S is 0 and x is 1. So 0 plus 1 plus 2 plus 3 plus 4 plus 5, and I am printing the value each time. As soon as x reaches 5, I am using the exit function, I am getting out of the main function. So because I am using exit only, I am using process.h. And here I am doing main plus x. So this is the actual place where x gets incremented. That is how x each time becomes 1 and 2 and 3 and 4 and 5. So this is an example of how this main function calls the function itself. So the main keeps calling itself again and again. So this is just a small example for recursion. So the possible questions that could be asked in the session are the methods by which arguments are passed, call by value and call by reference. The word meaning of recursion is where a function calls itself repetitively. Direct and indirect are the types. The operators that can be used with the function call, we have unary, binary, and all types of arithmetic operators can be used like addition, subtraction, multiplication, division, modulo. Two types of recursion also we have seen, direct and indirect, and the different forms of the return statement was with pointers, addresses, type conversion functions, simple functions, and expressions. So this is a summary of what we have seen in today's session, the different forms of return statement, the argument passing methods, the example programs, and the functions with operators and arguments. So this is the completion of the functions topic in C. Thank you.